So let's say you had two equations. One is x plus 2y is equal to 9, and the other equation is 3x plus 5y is equal to 20. Now, if we did what we did in the last video, we could graph each of these. These are lines. You could put them in either a slope-intercept form or point-slope form. They're in standard form right now. And then you could graph each of these lines, figure out where they intersect, and that would be a solution to that. But it's sometimes hard to find, to just by looking, figure out exactly where they intersect. So let's figure out a way to algebraically do this. And what I'm going to do is the substitution method. I'm going to use one of the equations to solve for one of the variables, and then I'm going to substitute back in for that variable over here. So let me show you what I'm talking about. So let me solve for x using this top equation. So the top equation says x plus 2y is equal to 9. I want to solve for x, so let's subtract 2y from both sides of this equation. So I'm left with x is equal to 9 minus 2y. This is what this first equation is telling me. I just rearranged it a little bit. The first equation is saying that. So in order to satisfy both of these equations, x has to satisfy this constraint right here. So I can substitute this back in for x. We're saying this top equation says x has to be equal to this. Well, if x has to be equal to that, let's substitute this in for x. So the second equation will become 3 times x. And instead of an x, I'll write this thing, 9 minus 2y. 3 times 9 minus 2y plus 5y is equal to 20. That's why it's called the substitution method. I just substituted for x. And the reason why that's useful is now I have one equation with one unknown, and I can solve for y. So let's do that. 3 times 9 is 27. 3 times negative 2 is negative 6y plus 5y is equal to 20. Add the negative 6y plus the 5y, add those two terms. You have 27. See, this will be minus y is equal to 20. Let's subtract 27 from both sides, and you get, let me write it out here. So let's subtract 27 from both sides. The left-hand side, the 27s, cancel each other out, and you're left with negative y is equal to 20 minus 27 is negative 7. And then we can multiply both sides of this equation by negative 1. Multiply both sides by negative 1, we get y is equal to 7. So we found the y value of the point of intersection of these two lines. Y is equal to 7. Let me write it over here. Y is equal to 7, so I don't have to keep scrolling down and back up. Y is equal to 7. Well, if we know y, we can now solve for x. X is equal to 9 minus 2y. So let's do that. X is equal to 9 minus 2 times y, 2 times 7. Or x is equal to 9 minus 14. Or x is equal to negative 5. So we've just, using substitution, we've able to found a pair of x and y points that satisfy these equations. The point x is equal to negative 5, y is equal to 7, satisfy both of these. And you can try it out. You could try it out. Negative 5 plus 2 times 7, that's negative 5 plus 14. That is indeed 9. You do this equation. 3 times negative 5 is negative 15 plus 5 times y plus 5 times 7. So negative 15 plus 35 is indeed 20. So this satisfies both equations. If you were to graph both of these equations, they would intersect at the point negative 5, comma